Now, for the sake of brevity and time constraint, and also as to remain agnostic to your experience with coding, we're not going to code this game line by line, and I'm going to bring in code that you'll be able to download with the project files, and we're going to briefly go over it to see what each function does. If you're a veteran scripter or if you're a novice, you'll be able to watch our further tutorials on programming for programmers and programming for beginners. So let's bring in our scripts. Going to create a code folder within our assets. Going to bring in our code. We've got one for the manager and one for the points. Unity is going to import them. Okay, there we are, code. See that it has some references here. It's fine. We'll address them as we bring them into the game object. So the manager is going to go onto our manager. And it has our audio source, and it has the script here as the component. So let's go into the script first and take a look. Okay, so both of these are namespaces that we're going to be bringing in. The Unity engine is the most of the scripts for that Unity provides for us. The system collections is something that's going to be available with C#, and specifically it's made available by default with Unity is because it uses something called coroutines, which we'll encounter later on in our scripts. So we can see that the class begins. The class will need to have the exact same name as the name of our game object, otherwise it cannot be added as a component. That extends the monoBehavior class, which is a class that we're going to be using certain methods from. And now we're going to be assigning some public variables here. Now, we're doing this because we can change these values actually within the editor itself, as you will see here. Currently, they're all set to 0, and that's fine. Okay, we have a reference to our hero, to the environment sphere, and we have the audio clip here. This is going to be a private variable. Let's move direction. You will see this later on. It's a vector3, and that means it simply has 3 floats that are with each other, which would specify a coordinate in 3-dimensional space. The animator is going to be the mechanism component. The character controller is what we're going to be using instead of a rigid body, and we will attach this soon. Okay, so the start function is going to be called in the very beginning, the object, when the object is enabled. Now, we're going to be assigning a variable to the component animator that we're going to be drawing from the blockman, from our hero. The character controller will do the same thing. And then we're simply going to take this environment sphere and we're going to enable it. So you'll be able to see it in our game, but we don't need to see it in our editor because it simply gets in the way. Now the update function is called every single frame. So in here we're assigning some floats here to the floats from Unity's input class, vertical and horizontal. And all of these you can see in your project settings if you go to input, horizontal and vertical. See A and D, and vertical is W and S, and up and down. So all of these are going to go from -1 to 1. So all of these values will be either -1 or to 1, depending on how long we press either one of the buttons, left to right, A and D, up and down, W and S. Okay, so this is going to, remember those variables that we set in mechanism? This is going to take all of these variables, and then it's going to take the absolute value of either one of these numbers, because if it's -1, we don't want -1, we want 1, so the rotation will switch from running to turning. And we want the same thing to happen with translation, so when the value is 1, the character is running. This applies the gravity to our character controller. If you're using a rigid body, you can also use gravity, but we are not, simply because it is simpler to use Unity's character controller script instead. The move function of character controller then moves our character in this vector 3 according to the amount of seconds passed, not according to the amount of frames. So this will make our game frame independent. So a slower machine will function the same as a fast machine. This is a conditional statement that asks whether our character is actually on the ground, which checks the character controller class. The move direction, which is a variable we've declared earlier, will be a overall almost a complete zeroed out vector 3, except for a control for forward and backward of our characters simply on the z-axis. Then it will take these values and it will transform it from a world value to a local value. And then also, considering this is -1 to 1, we might move our character a little faster, so we're going to multiply it by a factor. This then gets the value jump, which is once again found in the project settings, and then axes from the input field within the settings of your game. And upon pressing that button, we will have several effects. First of all, the position, the Y position, is going to be set to the jump speed, which we specified earlier. The character will then play the jump motion, the animation motion that we've specified within Mechanim. The audio clip, which we've seen in the editor, here we don't have one assigned, will then be assigned dynamically from this sound up here. Okay, and that is just simply going to play the sound. This rotates our character. So left-right amount, -1 to 1, multiplied by a factor. That takes this frame, makes this frame rate independent, and rotates around the y-axis. Okay, so before we can make this script work, we're going to attach a character controller onto our Blockman. Add component, character controller, and there's a collider here. So let's match this collider to our character. Offset the Y. Okay, that looks pretty good. Now, in our manager, we take our hero and we just drag him onto this reference field. We're going to do the same thing with the environment sphere. And this audio clip we're going to draw from the project directory, the jump. So let's set up a few test variables here just to see how it rotates. Well, let's set this to 1 at first, and we'll see that actually multiplying it by 1, we don't have to multiply this by a factor. And the jump speed, we're going to give this, let's say 5. And the gravity, we'll say 15. Okay, let's give this a try. We have a jump. Our character is actually turning, but very, very, very slowly. You might not see it, but if we multiply this by, how much? 150. Let's see. Okay, yeah, that's a little better. And our Mechanim animation is playing here as well. We can see that it's currently idle. Now watch these arrows as I press the turn button. And there he goes. I turn, and then the condition is off. The rotation is currently back to 0 in the parameters. Let's try moving around. Once again, we're moving, but very, very slowly. Maybe assign this to 3. Okay, and okay, great. So we currently have our character moving. And we probably do not want our game to look how it is here. So let's remember these values, or probably even better on, write them down. I'm going to remember them, 3, 150, 515. Okay, well, these are already set. Okay, let's take our camera. Where is it? And we're going to, well, okay, so first of all, I should say that there is a better way of doing this, and there are some great scripts online to have it follow the character around. In this case, we are simply just going to parent it under the hero. Okay. Okay, so our character is going to be moving towards the z-axis, so let's see. Okay, so there's the z-axis, there is the front. Let's go back to the camera. Currently see what the camera is seeing. Let's put this a little bit higher. Okay. Rotate it. Once again, the preview is here. Okay, and let's give this a test. Go to the default view just to see the window a little bigger. Okay. The camera is seeing fine. Now if we parent it, we should see it moving around. Let's reset the game. And simply parent it under the main blockman game object. Okay. Okay, so now the object is going to be moving around. We see our essence here. We haven't coded that yet, so that's just playing by default. And our object is passing through. Our sound is playing. Okay, let's just code in the last bit. So our other script is going to be the point collector. And the point collector is going to play a sound, and it's going to also add an effect to the ball, which we'll see in a moment. Okay, so we opened up the file with MonoDevelop. All of these we have already covered. Once again, we have some public references to the audio clip and one to also the particle system that we're going to be attaching, and just private Boolean, whether we have actually collected this object, so it won't continuously play and call functions. In the beginning, we're going to be referencing the particle system, the essence, and we're going to tell the particle system to clear and to stop. So these are just functions within the particle system class. This is a specific function also within Unity. It's called onTriggerEnter, and it references a collider within the sphere. So our object won't collide with it. It will still be able to go through, but it will be triggered. If we take this off, you can see the effect, the difference between the two. Okay, so now it won't even let us pass. Okay, we seem to be getting some sort of error up here. Null reference exception, object reference not set to an instance of an object. So we have current references here, and the references do not address anything. That's because we haven't had the particle system attached onto our point collector. So let's go in here, go into our ball essence, and attach two things. First, we need the essence, which is going to be the particle system, because it has the particle system component, which is the class. And then we also need to connect the sound. So now let's clear this out and let's see if we don't get any errors. Okay, seems to be functioning pretty well. Okay. And now you see that we don't have the essence because it's been turned off, but now we can't pass because it's still a collider and it's not a trigger. So let's continue looking at our script. We have the onTrigger function, so whenever an object enters the trigger within the collider of the object that we specified, within this variable, within this instance of the collider class, and if the collision tag or the tag of the object is going to be player and the object is not collected, so if this is still false, then it's going to start this special function called ball collected, called a coroutine, and it's going to set this variable to true. So we haven't covered two things up here. There's going to be a tag in the tag field of the blockman. You're going to see player. If you don't have a player tag assigned, you can create a new one called player. I'm getting an error because I already have it registered. I can delete this. So the other thing we haven't covered is a coroutine. And the coroutine is a special type of function, but one that can pause the execution and not have everything run on one single frame. In this case, we're also going to introduce a time delay of 2 seconds. After we've completed a certain amount of commands, then after that time has passed, we want to complete the rest of this function, ball collected. So at first we are assigning the audio to endgame, to this reference audio clip that we have up here. We play the audio clip, then we take the renderer of the current object, which considering the script is going to be assigned on the ball. The color of it is going to be green. We're going to set it to black, wait 2 seconds, and then we're using essence, which is our reference to the particle system. We're going to play the particle system, and then we're going to destroy the game object. We're going to destroy the ball. And considering we've already set the essence to play, this will not affect the essence, but it will destroy the game object. So let's see this in action. Okay, so we want to set the sphere here, the collider, to isTrigger. Okay. All the references are set. And let's test it. Okay. Okay, so there are our rings. Pretty cool. Okay, now just to finish this up, let's set up a few more up here to replicate the demo that we had in the beginning. I'm going to the for view mode. I'm going to take this point. I'm going to duplicate it. Let's place one here. And place one in here. Okay. Okay, and let's save. And there is our essence. Oh, looks like we're stuck. Ha. Okay, we can actually, I've been wanting to make this a little bigger. Let's go into our split view and just make some final tweaks. Just going to scale it in all the axes. And then considering we've done that, we want to realign our objects. Okay, and we're going to change our lights so that they are within the scene. And this one looks already aligned, and this one a little further. I just pressed Shift Space in order to maximize this window. Okay, now we've got definitely a bigger ceiling. There's our essence. And we can pass through the hallway. Okay, well, it looks like our objective here is complete. Okay, let's do one more thing before we finish off this tutorial and compile the game.